Hey there, welcome to another video on math problem solving. This is Bharat Divyang from Swang Academy, and today we've got an interesting problem from the UWash Math R Olympiad. Now, this is a very, very different kind of Olympiad exam. Unfortunately, I think only people from the state of Washington can participate, or maybe a US citizen who's probably going to be visiting Washington could participate. There's an in-person Olympiad tournament slash exam. What's interesting about this format is that unlike most other Olympiads, which are either MCQs or like online digital exams, this one is very much in person, where you'd be given only 5 questions that you need to answer over a period of 3 hours, and the way you answer is to actually talk to a judge and explain it out. At least that's what I gather from the website and from students who participated in it. So if you ever get a chance to register, please do so. June 1st is the exam this year, the event this year, and May 11th, which is today, is the last day for registration. All right, coming back to the problem. So this was asked in 2016 for grade 6 and 7. So remember, this is a middle school problem. It's not very difficult. If you were, more comfortable solving higher level problems. But I want to kind of look at it in two different perspectives. So the first one is, can you explain the problem logically? Maybe just use a combination of English, logic, and common sense and be able to explain the solution to this. The second one is, how do you actually turn this mathematical? Is it possible to mathematically prove what the value would be? And we'll try and do both of it. And that is our goal for today. So I'd like you to pause the video, read the question, and try and see if you can answer it in either the first or the second method. All right, welcome back. I hope you had a good opportunity to think about this problem. Most problems have to be modeled, and models come only when you actually cogitate, which means think about the problem, play around with it, take a paper, write it around, and then see if you can get the answer. So let's read the problem. So we have 3 two-digit numbers written on a board. One starts with 5, which means it's 50 something. The second one is 60 something, and the last one is 70 something. Annie, which is A first, tries to add the first and second number. Benny tries to add the second and third number, and Denny added the third and first number. Could it be that one of these sums is equal to 148 and the other two sums are 3-digit numbers that both start with 12? Which means, could it be that if the sum of two numbers were 148, then the sum of the other two pairs has to be something that starts with 120, in the sense it's between 120 and 129, 10 possible numbers. So this is your problem. So let's first try and solve it without the math behind it, which means let's think about it in a very logical way. So 140 is a pretty large number. So even if I take up, say, 50 and 60, so even if it's 59 and 69, you still end up getting only 50 plus 60 is 110, plus 18 is 128. So you're far, far away from that. So you got to bring the larger numbers into the picture. So the larger numbers are going to be 70 something and 60 something. So let's add the tens together. 70 and 60 together is going to make it. So the numbers are 50 something, 60 something, 70 something. So if I were to add the first two, I would end up getting 110 plus the digits, the maximum of which is 18, and therefore it is 128. So in order to reach 148, I need to add the larger of the three numbers, which is 60 and 70. So 60 and 70 together makes it 130. And again, I know that the largest possible number that can be reached is 18, and that's the only way I can reach 148. So I can come to a logical conclusion that I would end up getting 69 and 79 as the only two numbers if I need a sum of 148. So therefore, I'm left with 50 something. So 50 plus, I don't know what that is. But let's think about it. Like, let's add 50 and 69 together. So remember, this is 1 less than 70. So if I add only the tens places, I would get 120 minus 1. So it's 119 plus the unit digit of the 50 number, right? And if I add both of this together, sorry, not this, the 50 and 79 together, then remember 50 plus 80 is 130. So 130 minus 1 is 129 plus the unit digit. So in other words, when I add the sum of the other two things, I end up getting 119 plus u or 129 plus u. So the only way this number would still be in the 120 something is if u is equal to 0. And if u is equal to 0, the other one would end up getting 119, and therefore I would never be able to get both of these sums to start with 1, 2. It's not possible. So the answer to the question is it's not possible to have this. Now, how do you do it mathematically? That's the second part of the question. So to do it mathematically, let's try and pick another color. Let's do the blue one. To do it mathematically, let's think of the numbers to be, the first number is 50 plus a. The second number is 60 plus b. And the third number is 70 plus c, where 0 is less than or equal to ABC, which is less than or equal to 9. Also, A can be equal to B, can be equal to C, right? So there's nothing preventing it from not having the same digits. Okay, so now that we have this, I know that I need to get to 148. So if I mathematically combine these two together, I end up getting 130 plus B plus C is equal to 148. And therefore B plus C is equal to 18. And remember the inequality that B plus C has to be less than or equal to 9. So the only way this works is if B is equal to C is equal to 9. So this number ends up being 69 and this number ends up being 79. Now let's take the pair of the first and second number together, in which case you end up getting 50 plus A plus 69, which is 119 plus A. And let's take the first and third together, which would give you 50 plus A plus 79, which is 129 plus A. Okay, so if these are my two sums and I need 119 plus A to be less than or equal to 120 and less than or equal to greater than or equal to 120 and less than or equal to 129. And similarly, I would also need 120 to be less than or equal to 129 plus A less than or equal to 129. So the first inequality can be solved by subtracting 129 on both sides, and I'll end up getting 1 would be less than or equal to A, which should be less than or equal to 10. Okay, that's one possibility. And in the second one, when I do the exact same thing, I would end up getting minus 9 should be less than or equal to A, which is less than or equal to 0. Right, now put this along with the other inequality, which is 0 less than or equal to A, which is less than or equal to 9. So the only way this works out is if I take these two together, then A is equal to 0. But you need all three of them to work out, and that's impossible. There's not a solution for this set of inequalities. And therefore, since there is no solution to this, you would never ever be able to come up with three numbers which start with 5, 6, and 7, such that the sum of two numbers is 148 and the sum of the other two is somewhere between 120 and 129. Alright, so I hope you liked the video, you liked the methodology and the perspective with which I solved it. If so, please do like, share, and subscribe, and I'll see you in the next one. Thank you so much.